Hi, my name is Wong Chen Yao. Today, our group from Manufacturing Process Section 33 is going to present our case study for the kick scooter. But first, let me introduce the member of our group first, which is Liu Seng Ren, Wong Chen Yao, Noor Barziza binti Muhammad Rusdi, and Wan Muhammad Rifki bin Wan Muhammad Asmi. First, let me introduce you about the definition of kick scooter. It is a vehicle that has platform for rider standing, kickstand for parking, T-bar with hand grip for directional control, and also an adjustable clamp for T-bar height. The number of the wheel can be 2 or 3 based on the customer needs. It is ideal for short distance travel due to its convenience and also popular for recreational activities such as parkour and park rides. The targeted audience is primarily designed for kids and teenagers for daily use and recreational activities. By analyzing the materials that used for kick scooter production, the materials that used for making kick scooter frame is including aluminium, steel, and titanium, which are chosen for mechanical properties to withstand stress. For the small components, the wheels are made with plastic core embedded in polyurethane thread, which is effective for the urban surfaces. Then, the hand grips are made from the foam, rubber, or a combination for comfort. For manufacturing process of kick scooter, the options are including welding, mechanical assembling, and others. The balancing between quality, cost, and time is crucial because the excessive cost and time will impact the product affordability. While considering the manufacturing planning, the balancing between quality and cost is important. This is because the excessive manufacturing cost will impact the customer affordability. On the other way, the low product quality will affect the safety and company reputation. For the project score, we are going to analyze the material selection and manufacturing processes and find an optimal method selection for the kick scooter production. The aim is to optimize the company profits. For the history development of the kick scooter, it is first invented in 1817 in Germany by Karl, and the initial concept is known as Dreisine. The purpose of this invention is to become an alternative to horse-drawn carriage due to rising horse feed prices. The riding method of this Dreisine is running while sitting on it. The results show that it is an alternative and more convenient for short distance travel than a carriage. Then there is a company named Visa Gloria AG from Switzerland that involved in children's toy production, recognized that there is short transportation needs among children in 20th century. So they produced the first distinguishable children's scooter with wooden wheels and trademark flag. This commercial success meant this product has been manufactured for over 50 years. After that, there is a company named Sulzer from Switzerland play a significant role in kick scooter development by introducing easy-to-roll solid rubber wheels for skates and skateboards. This inspired Edmondo Duarte to invent the kick scooter prototype using a sturdy base, bicycle fork, rubber wheels, and chakra plate. This prototype is still presented in the National Museum of Switzerland. Finally, the time flies to 1990s when modern kick scooters has been invented. It is all started from Wim October's need for a link to Sternen grill sausage vendor. So, he invented a affordable two-wheel metal kick scooter that made of aluminium. This is an important shift from heavy wooden structures to lightweight transportation. Until now, the kick scooters has become the hip leisure devices for jumps and stunts. For the method of production, it is all starting from cutting and punching raw aluminium material with auto cutting machine. The material selection is based on cost and the targeted customer, while considering the aluminium types 6061 or 6063 due to their hardness degree. For deck formation process, it is including molding, shape modification, and welding of processed aluminium. First, the local shape and width will be molded by using punching die. Then, CNC machine will be used for adjusting the dimensions of the deck. After that, the heat treatment will be given to the deck for mechanical properties strengthening. Finally, the deck will undergo the surface treatment process such as powder coating, spray painting for appearance, and oxidation prevention. For handlebar, the similar manufacturing process to deck will be given such as cutting, shaping, welding, and heat treatment. The material selection for making handlebar will be steel, which has general extensibility, grip hardness, and low cost, aluminium with superior elasticity but higher cost, chromoly 4130 with greater elasticity and elongation but with highest cost. For wheel manufacturing, the polyurethane with rebound properties of 60% to 90% will be used for external material. The wheel core will be made of plastics like PP, ABS, and PC. The colors for external part and wheel core will be customizable. And finally, the assembly of different parts will be proceed with logo placement on selected components. Now let me explain the function of the kick scooter. The physics law that involved in the motion of kick scooter is the Newton's law. There is 3 Newton's law. The first is Newton's first law of motion, which is the law of inertia. The scooter will be at rest or in uniform motion until external force is applied, which is the rider's kick. The rider's kick will overcome the inertia, initiating the motion. Secondly, is the Newton's second law of motion, which is the force and acceleration. The acceleration of the scooter is directly proportional to the force applied by the rider's kick, which force is equal to mass times acceleration. Finally, is the Newton's third law of motion, which is action and reaction. The rider's kick creates an action force on the ground, then an equal reaction force will propel the scooter in the opposite direction to the kick. After we have an understanding about the physical law that involved in the motion of kick scooter, let us talk about the practical application. The first application is it is suitable for short distance travel. It is ideal for commuting to work, school, or nearby destinations. It is quick and efficient for distances impractical for walking, but too short for motorized transportation. Other than that, it is also have the ability of traffic avoidance. It has the maneuverability in crowded areas and traffic to avoid traffic jam because of its compact size that allows easy navigation. About its health and recreation benefits, it allows us to exercise and core strengthening. This is because it can work legs and core muscles and also increase cardiovascular health. Other than that, it is a fun leisure activity for all ages and do not require high skill for promoting. In short, the kick scooter functionality is based on Newton's law of motion. It also has practical application for short distance travel and traffic avoidance, and finally has health and recreational benefits for users of all ages. For the assumption on the type of manufacturing system, batch production method is recommended for kick scooters which can emphasize on flexibility compared to mass production. Due to its flexibility, the specification and design changes can be made, such as changing size, color, and pattern for each batch. This can help to respond to the market trends and customer preferences quickly. Other than that, semi-automated production flow can be arranged in the production, which the workers are set up in the sequence for task completion and efficient production. The CNC machining can be utilized in the production flow line for high precision and consistency across components. For the assembly process, skilled worker will be handling welding and mechanical assembly. During assembling the product, they can focus on maintaining product quality. After that, due to the benefit of batch production, customization can be done for each batch to meet market demands, and the use of resources will be efficient due to its flexibility. Briefly, the batch production method for kick scooters offers flexibility. CNC machining can ensure the precision in component manufacturing, and trend workers will be handled assembly for quality assurance. For the assumption on the quantity of the production, we need to do the market analysis first. From the research, the market size in 2018 is 470.5 million USD, and expected CAGR is 26.3% from 2019 to 2027, which indicate a large and growing market. About the quantity decision factors, there are a few of consideration. First, the large market size does suggest potential for higher production. Next, it is about the intense competition with the major players in the market, such as Razer LLC, Software LLC, Unagi Scooter, and Fusion Scooter. Finally, it's about the balancing of the quantity with the focus on quality. After that, the decision has been made. The strategy we are going to proceed is the production of quality over quantity. This is because of the competitive edge. We acknowledge that competing on quantity alone might be challenging, and emphasis on quality will be our major development factor. About the market potential and quality development, balancing quantity with the need for quality improvement is essential due to we need to take care of both market size and competition. Lastly, positioning the kick scooter brand through quality and innovation is also needed for competitive development. For the product cost estimate, the material cost and labor cost will be considered in calculation. In the material cost, the usage and cost of 6061 aluminium and polyurethane will be calculated. We assume that both of their usage for each scooter is 1 kg, and the cost of both material is 14.61 ringgit per kg and 8.01 ringgit per kg respectively, according to the market research on Alibaba. The total material cost will be 22.62 ringgit per scooter. After that, for labor cost, we assume that the number of workers involved in the production is 10 people, and the hourly wages is given to them in minimum wages, which is 7.21 ringgit per hour, and also the work duration for each scooter is 30 minutes. Then the total labor cost will be 36.05 ringgit per scooter. Finally, the rough estimated cost per kick scooter will be 73.28 ringgit. Actually, there also have other additional cost elements which is complicated for calculations, such as packaging, shipping, logistics, overhead, marketing, QA testing, R&D, contingency, and others. It is also important to consider all of these cost elements for accurate estimation. After considering all of these elements, the cost of a kick scooter might roughly be 200 ringgit. In a nutshell, the initial estimation is based on minimum material and labor cost, which is 73.28 ringgit per scooter, and the final estimated cost is roughly 200 ringgit per scooter due to the awareness of various cost elements.
We will be delving into the crucial work of material selection for scooter components. As we know, the right materials can significantly impact the scooter performance, durability, and overall quality. Let's kick things off with the scooter bars. We have several options to consider. Firstly is the steel SAE 4130 with a density of 7.85 gram per centimeter cube, use strength of 460 megapascal, and a brittle hardness of 270. SAE 4130 steel provides a robust and cost-effective choice at $130 per ton. Next is Aluminium 6061. Lightweight with a density of 2.7 gram per centimeter cube, a U strength of 276 megapascal, and a Brunner hardness of 95. However, it comes at a higher cost of $220 per ton. Next is Titanium 6A1 per 4V. Known for its strength, titanium has a density of 4.43 gram per centimeter cube, a remarkable U strength of 828 megapascal, and a Brunner hardness of 334. However, it's a premium option at $10,000 per ton. Finally, is the carbon fiber, boasting a low density range of 1.15 to 2.25 gram per centimeter cube and a wide U strength range of 4.62 to 3,200 megapascal. Carbon fiber is a lightweight but costly choice at $21,500 per ton. Now, let's talk about the materials for handle grips and grips end. Here are some options. First is the thermoplastic elastomer, known for providing excellent flexibility, elasticity, and grip comfort. Thermoplastic elastomer at an affordable cost of $2 to $5 per kilogram. Next is nitrile butadiene rubber, offering good grips, durability, and compatibility with oil and lubricants. NBR is priced between $2 to $4 per kilogram. Next is silicone, with excellent heat resistance, water repellent, and a soft, non-slip surface. Silicone is available at $8 to $15 per kilogram. Next is polyethylene. Providing good durability, polyethylene is a cost-effective choice ranging from $1 to $2 per kilogram. Finally, is polypropylene, striking a balance between strength, flexibility, and chemical resistance. Polypropylene is priced between $1 to $2 per kilogram. Moving on to handle and wheel bracket materials. First is steel, recognized for stability and resistance to wear. Steel has a density of 7,750 to 8,050 kg per meter cube, a melting point of 1,370 to 1,480 degrees Celsius, and the modulus elasticity of 200 gigapascal. And aluminium, offering improved mobility due to its lightweight, aluminium has a density of 2,640 to 2,780 kg per meter cube, a melting point of 660 degrees Celsius, and a modulus of elasticity ranging from 78 to 79 gigapascal. Now, let's focus on the Scooter deck. First is a chromoly steel, providing extra strength with longevity through a leading to a heavier deck. Next is aluminium alloy, striking a balance between structure, integrity, and mobility due to its lightweight qualities and strength. Finally, for the wheel tires, we recommend rubber compounds, vulcanized rubber, ensuring enhanced durability, high traction, wear resistance, and flexibility. So, in conclusion, the right material selection is paramount for optimizing scooter performance and longevity. Each component plays a crucial role in understanding the properties and cost of materials, allow for informed decision-making in the design process. Now, let's focus on the crucial elements that propels the scooter, the front wheel. This component is the driving force that allows the scooter to move forward, backward, and turn in different directions by rotating. The front wheel of a scooter serves as the primary means of mobility. It allows the scooter to move in various directions, making it a pivotal component for the overall maneuverability. By rotating the front wheel, riders can easily control the scooter's movement, giving them the flexibility to navigate through different terrains and scenarios. Moving on the back brake, an essential feature that allows riders to control the speed and halt the scooter effectively. The back brake is a critical safety feature of a scooter, providing riders with the ability to slow down and come to complete stop. These components allow riders to apply friction to the wheel, offering control and ensuring a safe and controlled riding experience. It plays a crucial role in enhancing the overall safety of the scooter. Next up is the grip tape, a seemingly small but significantly component that directly impacts the rider control and stability. The grip pad on scooter may appear stubborn, but is so crucial in ensuring the rider's stability and control. Placed on the deck, the grip tape improves the rider grips, reducing the risk of slippage during rides. This simple yet effective addition enhances the overall safety and comfort of the scooter, especially during dynamic maneuvers. Now, let's shift our focus to the deck. An integral part of the scooter deck provides stability and support to the rider. The deck of a scooter serves as the rider's foothold, offering a stable platform for the rider to stand on during the journey. It plays a crucial role in maintaining balance and providing support throughout rides. The design and material of the deck directly influence the rider's comfort and confidence, making it a key consideration in the overall scooter construction. Let's now discuss the clamp, a small but vital component that ensures the handlebar remains secure during rides. The clamp on the scooter might be easily overlooked, but its importance cannot be overstated. These unassuming components prevent the handlebar from loosening during rides, contributing to the overall safety and stability of the scooter. A secure clamp ensures that riders can confidently control the scooter without the worry of any unexpected handlebar movement. Now, let's explore the wheel bracket or fork, a component that significantly impacts the responsiveness and stability of the scooter. The wheel or fork is a critical component that affects both the responsiveness and stability of the scooter. It not only supports the front wheel, but also protects the wheel axle. These components allow for smooth steering, ensuring that riders can easily navigate their scooters with precision. The design and material selection of the wheel bracket are key factors in determining the overall performance of the scooter. Moving on to the bar, a central component that enables rider to control the direction of the scooter. The bar of scooter is more than just a handle. It is the primary interface through which riders control the direction of the scooter. By turning the bar, rider can navigate the scooter in their desired direction. Additionally, the bar acts as the center of stability for riders, providing a secure point of control during various maneuvers. Finally, let's discuss the grip bar ends, which serve a dual purpose of protecting both the scooter and the rider. Last but not least, the grip bar ends of a scooter play a multi-factor role. On one hand, they serve as protective caps, preventing injury or damage to both the scooter and the rider. On the other hand, they contribute to additional comfort during lengthy rides. This small but truthful addition enhances the overall riding experience, emphasizing the importance of attention to detail in scooter design. So, now we have delved into the engineering realm and explored the powerful application of geometric dimensioning and tolerancing, or GD&T. This method serves as a fundamental aspect of precision engineering, ensuring not only uniformity but also enhancing the efficiency and safety of manufacturing process. Let's explore the key aspect of how GD&T is a game changer in the engineering landscape. First is the global manufacturing standardization. Our first part revolves around global manufacturing standardization. GD&T plays a pivotal role in facilitating global manufacturing by standardizing design and product criteria. This standardization ensures uniformity in design and quality across international manufacturing. In the world interconnected market and diverse manufacturing facility, GD&T acts as a common language. By adhering to GD&T principles, manufacturers can standardize design and production criteria. This not only fosters consistency but also ensures that the products meet the same high quality standard regardless of where they are manufactured. The impact is profound, providing a foundation for global collaboration and competitiveness. Moving on to our second point, GD&T is instrumental in achieving interchangeable components, particularly in key areas such as chassis, handlebars, wheels, and braking system. Interchangeable components that seamlessly fit into place, GD&T ensures precise tolerance for proper assembly and interchangeability. This is not just a matter of convenience, it's vital for the smooth operation and safety of the end product. Whether it's the chassis, handlebars, wheels, or braking system, GD&T guarantees that each part aligns precisely, contributing to the overall reliability of the final product. GD&T is not just about dimensions, it's a language that effectively conveys safety and performance standards. GD&T serves as a communication tool for safety and performance standards. It guarantees tolerance for crucial aspects such as folding mechanisms, handlebar, alignment, and braking components. By adhering to GD&T, we significantly lower accident risk and enhance rider safety. It's not merely about meeting standards, it's about exceeding them to ensure the utmost safety and performance of our product. Our next point emphasizes the importance of structured alignment for stability. GD&T communicates alignment requirements for wheels, handlebars, and the other structured parts. For stability and control during usage, proper alignment is non-negotiable. GD&T becomes the language that precisely communicates these alignment requirements. Whether it's the wheels, handlebars, or other structural components, GD&T ensures that each part is aligned correctly, contributing to the overall stability and control of the end product. GD&T extends beyond dimensions. It defines material specification and weight consideration for various components. It's not about how things fit together, it's about what they are made of. GD&T defines material specification and weight for components, striking a delicate balance between durability and weight for optimal performance. This meticulous approach ensures that our products are not only precise in dimensions but also engineered for efficiency and durability. Let's explore how GD&T helps in reducing over-constraint, ensuring cost-effective manufacturing at scale. Over-constraint can be a significant hurdle in large-scale manufacturing. GD&T comes to the rescue by specifying essential tolerance for components function. This not only ensures the functionality of each part but also eliminates unnecessary constraints, paving the way of cost-effective manufacture on the grand scale. GD&T extends its benefit beyond the manufacturing phase. Clear GD&T requirements facilitate component design for maintenance and replacement. As products age or require maintenance, user or technician can confidently replace parts without compatibility concerns. This ease of maintenance is not just a convenience but a testament to the foresight embedded in the initial GD&T design. It's about creating products that stand the test of time and are easy to maintain. Our final point highlights how GD&T streamlines quality control operations, ensuring each component meets necessary criteria before assembly. Quality control is the heartbeat of any manufacturing process. GD&T standardizes design and production criteria, streamlining quality control operations. Each component undergoes meticulous scrutiny to ensure it meets the necessary criteria before assembly. This not only guarantees the quality of the final product but also reinforces the trust our customer place in our brand. In conclusion, GD&T is more than a set of rules. It's a language that speaks precision, reliability, and safety. From standardizing global manufacturing to ensuring interchangeability, safety, and quality control, GD&T is a cornerstone in the modern engineering. As we continue to push the boundary of innovation, GD&T remains our ally, ensuring that every component meet the highest standard of excellence.
Now we are going to talk about the alternative processes to manufacture each part of the scooter. The first alternative for the first part, which is scooter bar, is by using extrusion. The scooter bar can be made by extruding aluminium or other metals. The second alternative is by using casting. This technique can be applied to more intricate shapes or decoration. And then the third alternative is by using tube bending. If required, steel or aluminum tubes can be bent into the required shape before being welded. The second part is scooter handle grip. The first alternative is by using injection molding. Injection molding can be used for rubber or soft polymers. The second alternative is by using compression molding, a different approach from injection molding, particularly for silicon grips. The third alternative is by using dip molding. A mold can be dipped into liquid PVC to create PVC grips. The third part is the scooter handle grip end. The first alternative can be used by using CNC machining. CNC machining provides very high precision for metal ends. The second alternative is by using injection molding. For larger batch, this is an affordable option for plastic ends. The third alternative is by using stamping. Another option is to stamp metals and then slide them into the grip. The fourth part is the clamp. You can use CNC machining, which enables intricate and precise designs. Second alternative is by using forging, which produce robust parts, and then machining follows for accuracy. Or thirdly, you can use die casting. This technique can be used to create clamps made of zinc or aluminum. Next is the handle and wheel bracket. The first alternative is by using fabrication of sheet metal. Sheet metal is capable of being bent and cut into brackets. The second alternative is by using investment casting for intricate design with high quality surface polish. The third alternative is by using welding. As an alternative to custom designs, combining metal cutouts or forms can be done. Part number 6 is scooter deck. The first alternative you can use is CNC milling, especially for aluminum precision deck. And then the second alternative is by using stamping and welding. Form is created by stamping sheet metal, and then the strength is added by welding. The third alternative you can use is extrusion, especially for aluminum decks. Next, CNC machining for fine details and length trimming. The seventh part is wheel tire. The first alternative you can use is compression molding. Compression molding is a technique you can use to create rubber tires. The second alternative is by using injection molding. It is for polyurethane tires. And then the third alternative is by using liquid casting for customized urethane tires or small runs. And then next is axle. Axle can be made using cold forging, which can produce strong steel axles. Or alternative number 2 is by using turning. A lathe can be used to turn a metal rod down to the proper diameter. Or number 3 is by using the roll threading, since it is most robust than cut threading while producing the thread. And then the last part is nut. You can use is cold forming. This method can affordably produce big numbers of nuts. The second alternative is by machining for extremely precise or unique nuts. And then stepping. For a less important application, tapping the internal threads afterward can be an option. Every scooter component must have its best manufacturing option chosen. This requires careful consideration of a number of variables, including cost, accuracy, material qualities, and intended usage. Because of this, various production options have been chosen for each scooter component, according to their unique benefits in terms of effectiveness, accuracy, and affordability. The first part, which is the scooter bar, can be made using extrusion. It is because of the simplicity and the economy of cost. The second part, which is scooter handle grip, can be made using injection molding. This is because it is appropriate for soft polymers like rubber. The third part, which is the scooter handle grip end, can be made using CNC machining. This is because it is appropriate for metal ends with extreme precision. The fourth part, which is clamp, can be made using CNC machining also. This allows the complex and accurate patterns. The fifth part, which is the handle and wheel bracket, can be made using the fabrication of sheet metal. This is because it allows appropriate cutting and bending. The sixth part is the scooter deck. It can be made using CNC milling. This is because it is ideal and particularly for precise metal decks. Next is the wheel tire. It can be made using compression molding because it is appropriate for rubber tires. The eighth part is the axle. The appropriate manufacturing process is by using cold forging. This is because to ensure the robust steel axle. And the last part, which is nut, can be made using cold forming. It can be this is because it can generate big numbers at a reasonable cost. Lastly, we are going to talk about the stages of the total product manufacturing. The first stage is the frame fabrication. In order to create the framework of an aluminum frame, the metal must first need to be cut into the appropriate shape before being bent and welded. The second stage is component manufacturing. A variety of procedures are usually used in the manufacturing of the handlebar, wheels, brakes, and other components. The third stage is the surface finishing. After manufacturing the components, it goes through surface finishing procedures to improve their appearance and longevity. The fourth stage is assembly. In order to assemble the entire scooter, all of the manufacturing parts are combined. This entails fastening the handlebars, brakes, wheels, and more components to the frame. Lastly is the quality control. Throughout this entire production process, quality control is included. This involves checking at different points in time to ensure the components, materials, and finished assembly all adhere to performance, quality, and safety requirements.
I'm going to be presenting types of machine or equipment for each processes. We will see the picture and the final product of what the machine are capable of doing through this kind of process that we are listed here. And then second agenda is we're going to be looking at the sustainability practice at our kick scooter. So let's get into it. So as you can see in the slide, first one we have bending and cutting, second one is molding, third is CNC, computer numerical control, fourth is welding, drilling and punching, fifth is track loading, sixth is machining and using lathe machine. So for the first one, bending and cutting component involve scooter bar. So steel bar, first one is cut using band saws or laser cutting machine. Then it is bent through the CNC press brake. Later on, we're going to see the picture of the machine. Second one is molding. Scooter handle grip and wheel tire involve uses the injection or compression molding. After molding, rubber component undergo the vulcanization processes by vulcanizing presses. These processes improve the material strength, elasticity, and also resistance to abrasion. So third one is computer numerical control. So component involve scooter handle grip and clamp and also scooter deck. CNC machining and milling are used to produce this component. Raw material can be shaped into required shapes using CNC machining. CNC milling provide high precision, repeatability, and efficiency in the production of the scooter decks. So for the fourth one, we're going to be looking at the welding, drilling, and also punching. Wheel bracket and handle are the components that are involved. Welding machines such as MIG or TIG welders for securely joined components. Drilling or punching machine are also being used for creating holes and mounting points. Fifth one is thread rolling. Uses thread rolling as a process to make the axle. After the axle is put into the thread rolling, a series of rolling dies use pressure of rotation gradually shape the thread into an axle. Later on, we're going to see the lathe machine. The sixth one is machining using the lathe machine used to make nuts. Turning on lathe to shape the nut into desired form. This involves removing excess material to create basic structure of the nut. So we're going to be looking at the first one. This one is bending and cutting. As you can see, machine use are the band saws, laser cutting machine, CNC press brake, and this is the finished product, which is the scooter bar. Second one is molding. Machining, as you can see there is injection molding sketches to better understanding about the molding processes. So the example of mold is there, and then we use injection molding machine or compression molding machine. And then for the rubber, we use vulcanizing press machine. So the finished product are here. As you can see, the wheel tire, scooter handle grip, and also scooter handle grip. Third one is computer numerical control, CNC, computer numerical control machine, CNC, and also CNC milling machine that I use. So this is the finished products. As you can see, scooter handle grip, clamp, and also scooter deck. Okay, move on to welding, drilling, and punching. So machine use, this is the example of MIG welding machine, drilling machine, as you can see down there, and also punching machine, make the hole. And then wheel bracket, as you can see, the finished product are the wheel bracket and also the handle. These are the one that I mentioned just now, thread rolling. So these are the thread rolling machine, and also these are the finished product. As you can see, this is the kick scooter axles. And then the last one for this section is machining using lathe machine. So as you can see, this is the component operation of the lathe machine. You can see these are the lathe machine that I use to make the turning. So these are the finished product, which is the nuts. So last one I'm going to be that we're going to be discussing today is the sustainability, green development in manufacturing in this kick sticker. So first one, we're going to be talking about green manufacturing. Second one is business advantages. Third one is shift to steel in scooter manufacturing. Fourth is stages of steels. And fifth one is steel in natural disasters. Sixth one is steel industrial innovations. Seventh one is sustainable scooter practices. And eighth one is conclusion. Let's dive into to this point bit by bit. So greening manufacturing, revamping production for environmentally friendly operation, which is not cause harm to the environment. We also reducing the natural resources usage, curbing pollution, waste management, recycling, reusing, and controlling emission to the atmosphere. Second one is business advantages. As you can see, environmental initiative result in improved profitability. Recognition of belief benefits lead to increase of motivation, moral, and also positive public relation among employees. This is also going to boost your business. So third one is shift to steel and scooter manufacturing. Address environmental concern related to plastic decomposition. Scooter manufacturer shift into steel from plastic. These are because of related plastic decomposition issue these days. And also kick scooter design transition from plastic to steel for superior environmental friendliness. Fourth is advantages of steel, durable construction material with minimal upkeep. So resilient against various environmental conditions, outlasting wood or stone. Economic benefit, generate employment opportunity, contribute tax revenue to the local government. So, and the fifth one is still in natural disaster structure built with still minimize losses during natural disaster, safeguarding property and lives. As you can see, if you, for example, if you use plastic, also it easily have huge losses due to its property. Steel are more stronger than plastic. That is why. Six is the steel industry innovations. Ongoing innovation aim to reduce pollution in manufacturing and recycling processes. So they try to take up with the demand. So ongoing R&D being put into practice now, so that the material are stronger and also it less reduce pollution to the environment. So seventh one is sustainable scooter practices. So drive in scooter industry to integrate recycled material, prolong product durability, and harness technology. Micro-mobility system pioneers recycle ocean plastic for kids scooters, for example. Global's focus on emission-free scooters contribute to a more eco-friendly mobility landscape. And for final one is the conclusion for the sustainability commitment of the manufacturer to sustainable material practices to minimize the environmental footprint. Adoption of environmentally friendly material is pivotal for elevating scooter sustainability.
In conclusion, kick scooter production involves material selection, cutting, shaping, welding, and surface treatments. Modern kick scooters' crucial material selection includes steel, aluminium, titanium, carbon fiber, and polymers for high-quality, user-friendly, and durable scooters. Advanced manufacturing techniques and ergonomic design enhance performance and longevity. Adherence to safety standards ensures a high-quality final product. GD&T drawings play a vital role in kick scooter design and manufacturing, facilitating precise tolerances and standardized production. That's all from us. Wish you have a good day. Thank you so much for listening.